All right, let's get into it. Imagine if we could actually reach other stars, not, over centuries, but maybe in just years.
Yeah, a real game changer.
Exactly. So today we're diving deep into this really remarkable patent application. It's for a mercury-based electric power system. And the idea is, well, it proposes how we might actually achieve that kind of rapid interstellar travel. Our mission is to kind of unpack this blueprint, see how it works, and why it could completely redefine things.
And what strikes you immediately looking at this patent is how it just directly confronts the biggest roadblock: power, immense sustained power.
Right.
Current systems, solar panels, even the RTGs, the radioisotope generators we use, they just can't deliver. Not for the kind of high G propulsion you'd need.
Just not enough juice.
Not nearly enough. They're too weak, too heavy for their output, not efficient, and they don't last long enough for interstellar journeys. This patent is not just tweaking things, it's aiming for something fundamentally different.
Okay, so what is the core idea here? The patent talks about integrating two key things: a compact net-positive fusion reactor, which is, wow, amazing in itself,
Huge.
with this novel closed-loop mercury-based magnetohydrodynamic unit, MHD. That sounds complex. How does that combination actually generate power?
Well, it's actually quite elegant at its heart. It's about direct energy conversion. So the fusion reactor, it provides this just massive amount of heat.
Okay.
That heat superheats elemental mercury until it becomes a plasma, which is highly conductive. Now, here's the clever bit. You channel this flowing mercury plasma through a really powerful, very precisely shaped magnetic field.
Generated by superconducting magnets, it mentioned.
Exactly. Superconducting magnets. And basic physics, Faraday's law, tells us that when you move a conductor, in this case the plasma, through a magnetic field, you generate an electric current. A huge one.
So no turbines, no moving parts like that.
Pretty much. It converts heat directly to electricity via the plasma and magnets. That means potentially ultra-high efficiency, and you slash the mass because you ditch all those heavy mechanical components. It sidesteps a lot of engineering headaches.
That direct conversion, yeah, sounds incredibly efficient. Minimizing moving parts. That solves so many potential failure points on a long trip.
Definitely.
But, okay, mercury plasma. Superheated. For potentially centuries, that sounds challenging. How do you contain that? What about safety?
That's a critical question, and the patent really focuses on it. It talks about breakthroughs in material science.
Okay.
Think advanced ceramics or maybe composite alloys, things specifically engineered to handle extreme temperatures and the corrosive nature of mercury plasma for, decades or even centuries. This isn't just like a slightly better metal. It's a whole new class of materials needed.
And you mentioned the Aubergine spacecraft and its AI, Ethelon. How does the AI fit in?
Ethelon is absolutely crucial here. It's not just running basic automation. We're talking about constant, real-time, high-precision control. It's managing the plasma flow rate, tweaking the incredibly complex magnetic fields millisecond by millisecond to keep everything stable, perfectly optimized for peak efficiency and safety.
Yeah.
You couldn't realistically expect a human crew to manage that level of continuous fine-tuning.
Got it. So Athlon keeps this powerful but delicate system running smoothly, and the result is astounding power density, right? The patent connects this to a magneto-inertial drive, and MID, capable of sustained 10 grab acceleration.
That's the headline number, yeah. Sustained 10 grab.
Which means, radically faster trips to other stars. But hang on, sustained 10 grab, that's intense for human crew, even with fancy life support. Does the patent, or maybe the aubergine concept overall, touch on how people would actually handle that?
It's a good point. The patent itself is focused on the power source. But yeah, the whole aubergine concept implies that this level of power enables the solutions needed for those other huge challenges.
Like artificial gravity, maybe.
Yeah.
Or advanced shielding.
Exactly. The power system isn't just for the EV-ID drive. It's the central hub powering everything. Advanced life support, yes.
Yeah.
Artificial gravity, the AI itself. Onboard manufacturing to repair things. Active radiation shielding. All the crew habitats. Everything needed for a truly self-sufficient, decades-long mission. This power system is what makes that whole vision feasible.
Okay, so wrapping this up, what's the big takeaway here for you listening? This deep dive shows how one, admittedly very advanced invention could fundamentally change our relationship with energy and space. It could potentially untether us from the solar system, opening up genuine deep space exploration.
It really does reshape what we think of as possible. Imagine reaching another star system, not as some multi-generational crawl, but as a journey measured in, say, single-digit years.
Yeah.
Think about the discoveries that unlocks. What new frontiers, what new understanding of the universe would you be most excited to explore if that kind of power was real?